Welcome, pre-calc students, to the review sheet help video. Let's go ahead and get started with the problems. As you can tell, we have a lot to do. So let's go ahead and get started. Here we go. Problem number 1. Let me clear off my book here and look. The directions say to, and I'm on the wrong page, so give your old teacher a second here. Okay, name the trig function that is equivalent to the expression. So, pretty simple. 1 over cosine would be secant x. Okay, pretty simple. Moving on to number 5. Okay, cosine over sine is the same thing as cotangent x. These are called the fundamental trig identities. Okay, these are the basic ones that we've used quite a few times. All right, moving on to number 9. Okay, the directions say to use the given values and identities to evaluate the other trig functions. So here we go, guys. Remember the cofunction identities. Whenever you have sine of 90 minus an angle, that's the same thing as the cosine of that angle. Okay, let me put it to you like this. Sine of x equals cosine of 90 minus x, or pi over 2. And cosine equals sine of 90 minus x. Okay, that's called the cofunction identities. Cofunction identities. Okay, and notice right here we have sine of 90 minus x. So in place of this, I can put cosine of x. Okay, so what we have is cosine and sine. So what we have to figure out then is tangent, cosecant, secant, and cotangent. Okay, so let's go ahead and do this. Here we go. It should be pretty simple. Using trig identities, we know that if cosine of x is square root of 2 over 2, the reciprocal of that is secant. So secant would be 2 over square root of 2. And of course we have to rationalize the denominator, so 2 square root of 2 over 2. Those would cancel, leaving you with square root of 2. So there we go, there's secant, okay, right there. Cosecant's pretty easy because cosecant is the reciprocal of sine. So same thing, if sine of x is negative square root of 2 over 2, then cosecant would be negative, well, same thing as just down here, 2 over square root of 2. And then we rationalize the denominator, so negative 2 square root of 2 over 2. So negative square root of 2. Okay, that would be cosecant. Now tangent, as we know, let's go ahead and do it right here. I guess tangent is sine over cosine. Okay, so sine of x is negative square root of 2 over 2, and cosine of x is square root of 2 over 2. Now guys, come on, think about it. We have the same thing over the same thing. Look, if you have 5 million over 5 million, it's going to be 1. Anything over itself is 1. Okay, so we have the same thing over the same thing, square root of 2 over 2 over square root of 2 over 2, so it equals 1. However, there's a negative sign here, so negative divided by a positive is negative. There we go. Now, cotangent would be the reciprocal of tangent. So if tangent is negative 1, the reciprocal of negative 1 is negative 1. So here's your 4 answers. 1, 2, 3, 4. Okay, moving on to number 13. All right. The directions for number 13 say to use the fundamental trig identities to simplify the expression. So we're going to simplify number 13, okay? Well, first of all, if you will look at your basic trig identities, you will see some Pythagorean identities, and you will see that for your Pythagorean identities, cosecant squared x minus 1 is the same thing as cotangent squared x. Okay, so this became this. Now, tangent squared, I'm going to put it over 1, times the reciprocal of cotangent is 1 over tangent squared, So there we go. And now look at this, guys. You get tangent squared. Tangent times 1, 1 times tangent. You get tangent squared over tangent squared, which equals 1. Anything over itself equals 1. Okay? All right, number 17, we are still simplifying. So let's go ahead and take a look at number 17. The first thing I thought when I looked at this, I'm like, wow, what can I do to make this simpler? And I thought, well, maybe if I factor out a cosine squared, since they both have a cosine, I would be left with 1 plus cotangent squared. And that was a big help, guys, because if you look at your Pythagorean identities, for 1 plus cotangent squared, I can put cosecant squared. So now I have cosine squared times cosecant squared. Now that looks pretty good, but there is one other thing I can do. The reciprocal of cosecant is, okay, cosine squared over 1 times 1 over sine squared. Okay, so for cosecant squared, I put 1 over sine squared. Now multiply those together and you get cosine squared over sine squared. And cosine over sine is tangent. So tangent squared, no, that's incorrect. Sorry about that. It's cotangent. Sine over cosine is tangent. Cosine over sine is cotangent. Cotangent squared x. Okay, moving on to number 21. Okay, same thing. We're going to simplify. So here's what we're going to do. First of all, we're going to have to get a common denominator, unfortunately. So we're going to have to, first of all, slide this over here and get a little space. Second of all, get a little whiteout going on here. There we go. And now let's multiply the top and the bottom of each fraction by something. This fraction here, I'm going to multiply by cosecant theta minus 1. Okay, so that's going to give me cosecant theta minus 1 times 1 is cosecant theta minus 1 over, and down here in the denominator I'm going to have cosecant theta minus 1 times cosecant theta plus 1. There we go. Now, put your minus sign. I'm going to multiply this fraction times cosecant theta plus 1 over cosecant theta plus 1 because of this denominator here. What I'm going to have in the end, students, is a common denominator. So 1 times this would be cosecant plus 1, okay, over cosecant. Well, actually, it'd be this right here. I'm going to save some time. Hopefully, it won't backfire on me. That's not what I wanted. I'm not even a Gator fan. How's that? There we go. Alright, and we'll get that right there. Okay? Now, let's see what we have here. We have cosecant theta minus 1 minus this whole expression. So really, this is going to become negative, and this is going to become negative, and we'll make this a plus sign. So we have cosecant minus cosecant. They cancel out. We have negative 1 plus negative 1, so negative 2 over. Now, your common denominator, if you multiply these two together, take cosecant theta times cosecant theta times 1, negative 1 times cosecant, negative 1 times 1, you'll get this right here. Cosecant squared theta minus 1. All right? Now, we're doing really well, okay? However, there's a substitution I can make for cosecant squared theta minus 1. And that substitution is cotangent squared. Okay, so cotangent squared. Alright, now of course to finish up, really I have negative 2 over 1 times 1 over cotangent squared. Okay, that's pretty simple. And 1 over cotangent squared is really just tangent squared. So I end up with over 1. So I end up with negative 2 cotangent squared x. Okay, there we go. That's the simplification of number 21, I believe it was. Alright, 23, we are going to verify this trig identity. So here we go. Well, first of all, it's pretty obvious you can use a Pythagorean identity right here for this. So bring down your cosine, and then for this right here, tangent squared x minus 1 is the same thing as secant squared x. Alright, there we go. Now, secant squared is the same thing as cosine x over 1 times 1 over cosine squared x. Look at that. So you can take away one cosine here, take away one cosine here, and you're left with 1 over cosine, and 1 over cosine is secant. Secant x equals secant x. Okay, there we go. Not too hard. Okay, guys. And how did I get started on this? Well, students, I just noticed this right away. Whenever I see something squared with a 1, quite often I'm thinking maybe Pythagorean identity. Okay, so that's what I did. All right. Okay, moving on to 25. Okay, cosine of x plus pi over 2. All right, well, first of all, guys, remember, whenever you have cosine of two angles that you're adding together, we have our, what's it called? Sum identities, I believe they're called, and product to sum and sum to product or something like that. So this here would be called, and I am drawing a blank on, let me look real quick. These are called your sum and difference formulas. And so we're going to call this U. We're going to call this V. Okay? And whenever you have cosine of two angles being added together, you can rewrite it like this. Cosine of U, cosine of V. This should ring a bell, guys. Should be on your trig identity sheet. Minus sine of U, sine of V. So I'm going to write this. I'm going to write cosine of x, because my U is x, cosine of pi over 2, because my V is pi over 2, and then minus sine of x, sine of pi over 2. Okay, so there we go. Now, cosine of pi over 2 is 0. So now I have cosine x times 0. And here I have negative sine x. Now sine of pi over 2 is 1. So times 1. Well, students, cosine anything times 0 is 0. Negative sine times 1 is negative sine x. So 0 minus sine is negative sine x equals negative sine x. Okay? All right, moving on to number 27. Okay, here we go. Now, for number 27, the first thing I thought of is this. I have cotangent. If I take this and bring the tangent up top and bring the cosecant up top, I would have cotangent theta sine theta. Okay? Now think about it. Cotangent is the same thing as cosine over sine times sine over 1. Okay? So these would cancel, leaving you with cosine, which is exactly what you want to have. Okay? Alright, very good. Moving on to number 31. Okay, now I think on 31 and 35, notice they do not give you a domain like this. Okay, they do not. So we are going to have to add 2 in pi, okay, to our answers. Let's go ahead and solve this equation. This is a pretty simple equation. We're going to bring our negative sine x over to the other side and make it a positive sine x. So now I have 2 sine x equals square root of 3. Now divide both sides by 2, and you're left with square root of 3 over 2. All right. Now, what angle, when you take sine of that angle, gives you square root of 3 over 2? Well, it's going to be 60 degrees, okay? Pi over 3 or 60. So the answer is 60. Now, let's think this through, guys. In what quadrants is sine positive? Well, sine is positive here, and sine is positive here. So I want to put my 60 here. You guys remember how to do this? I hope you do. And put your 60 here. So one answer is 60. The other answer is 120. So you have 60 and 120. Now, usually you will want to give your answers in radians. So 60 is pi over 3. And 120 would be 2 pi over 3. Now, remember you have to put plus 2 n pi. Plus 2 n pi. And students, here's why. You can add 360 or 2 pi n times, as many times as you want to, and that number will be another solution to the equation. So since there's no domain up here, like this, then we have to put plus 2 n pi to let people know that the answers go on and on and on, over and over, 360 degrees or 2 pi over and over. Okay? All right, number 35. Okay, we're going to divide both sides by 3. And then take the square root of both sides. Okay, we're going to get plus minus square root of 4/3. Okay, now that gives us plus minus 2 over square root of 3. Okay, now that gives us plus minus 2 square root of 3 over 3. Okay, now think about it. If you look at your table, this is one of our special angles here. So if you look on your table, you're going to see that when you take the cosecant of 60, that's when you get 2 square root of 3 over 3. Now look what we have here, guys. We want all the angles that when you take the cosine of this angle here, x, it gives you out positive and negative 2 square root of 3 over 3. So we're dealing with all 4 quadrants, okay? So I'm going to quickly put 60 in all my triangles here. I'm going to go really fast, rotate up, one answer is 60. Rotate to here, one answer is 120. Rotate to here, one answer is 240. And then rotate all the way around, one answer is 300. Okay? Now, of course, we would have put that in radians, so it'd be pi over 3. And 120 would be 2 pi over 3. 240 would be 4 pi over 3. And 300 would be 5 pi over 3. So there we go. Plus 2 n pi, and then ditto marks, ditto marks, ditto marks, okay? So there we go. Hope that made sense, guys. All right. So we're solving some trig equations here. All right, number 39. Now 39, I believe they give you a domain. Yes, they do. So that's good. Now, okay, we got a problem, guys. We have a cosine and a sine. So really the only way to get this whole thing into sine would be for cosine here to put 1 minus sine squared plus sine x. Okay? Now we have all sines. Now, what do we got here? Let's see. A negative sine squared plus sine x, and then we'll put your positive 1 here, equals 1. But then, students, look, if you bring this 1 over and make it a negative 1, that's all going to cancel out. So you're going to have this right here equals 0. Okay? Now go ahead and factor out a sign, and you're left with negative sign plus 1 equals 0. Okay? Now, let's see what we have next here, students. We take this group here, set it equal to 0. And we take this group here and set it equal to 0. Okay? So there we go. Now let's see, what angles give you 0 when you take sine of 0? Excuse me. What angles when you take the sine of certain angles give you 0? What would be the sine of 0 and the sine of 180 would give you 0. Okay? And then what angle when you take the sine of, let's see, negative sine x equals, bring this 1 over, make it a negative 1. Then divide both sides by a negative 1. So there we go. So what angle when you take the sine of it gives you 1? And that's going to be 90 degrees. And that's it, students. I mean, those are the 3 answers, and they all fall in your domain right here of 0 to 2 pi. So these two and this are your answer. Now students, don't forget on your test, whenever the original problem has 2 different trig functions, make sure you take each answer and check each answer in the original equation. Okay, if you do that, in this case here, all 3 answers do work. Okay, so we're fine, but always get into the habit of checking. Okay, very, very important to do that. Okay, number 43. Okay, tough problem. This one's going to be a pain. I'll just warn you right now, okay? It's already factored for us, so we can take cosine of 4x, set it equal to 0, and cosine of x, and set it equal to 0. Now let's do this one first. This is the easy one, okay? So bring your 1 over and make it a positive 1. So we have cosine of x equals 1, okay? Now let me look at I've worked this out ahead of time. Let me find my sheet here real quick. Okay. It looks like the cosine of 0 gives you 1, and that's it. Okay? So there's one answer. I'm going to put it up here. Okay? Now we're going to need a bunch of room for the rest of this problem. This is where it gets really difficult. Okay? Now watch. We understand that the angles that when I take the cosine of that angle, that gives me out 0 are going to be 90 and 270. Okay, but here's the problem. X doesn't equal 90. 4x equals 90, because you're basically putting 90 in for 4x, and you're saying the cosine of 90 equals 0. So really what you have is this. You have 4x equals 90. Okay? Divide both sides by 4, and x equals 22.5. So there's one answer. Now, you have to take 90 degrees and add 360 to it, and get 450. And now try this number. So divide by 4, and you will get 112.5. Now listen, students, as long as these answers here for x are staying in our domain right here, then we're totally good. We got to keep going, okay? So here we got 112.5. That's still easily in our domain. So we got to take 450 right here and add 360 to that, okay? And we will get 810 degrees. So 4x equals 810. Now you can see why this is a pain. And you get x equals 202.5. So we're still in our domain. So we have to keep going, okay? So now I'm going to take 810 degrees and add 360 to it, and I'm going to get 1,170. Now divide both sides by 4, and I will get 292.5. Now, there is a little bit of a pattern you're welcome to see here and welcome to notice and use. From this answer to this answer, I added 90. From this answer to this answer, I added 90. From this answer here to this answer here, I added 90. So it's okay to assume the next answer is going to be 90 more. And that would put us at, what, 382. And that's outside our domain of 360. So we're finished with this. Okay, now we got to do all of this again with 270. Okay, and so this really is a pain. So here we go. Put our answers over here. And I know the back of the book has all of these in radians. On a problem like this, I am totally fine with you guys doing all of this work and then just leaving it in degrees. Is totally fine to do. No problem at all. Okay. Now let's deal with 70 degrees. So here we go. 4x equals 270. 270 divided by 4 is 67.5. Okay. And now let's take 270 plus 360. We'll get 630. Divide by 4, 157.5. So it looks like we're going to be going by 90s again. I'll do one more just to make sure. Alright, let's take 630 right here, and let's add 360 to it. 990. Now divide both sides by 4. We get 247.5. Okay, so it's okay. Look, if every time you can see we've added 90 over and over. So I'm going to add 90 again, and we'll get 337.5, which of course does fall in our domain. So these answers here. Wow, it's going to be a lot of work here, guys. These answers here are part of our answers. There's one here, one there, one there, and one there. So how many answers did we end up with? Let's see here. 1, 2, 3, 4, 5, 6, 9 answers. Okay, so that's a tough one, but it's a good one. But that's how you would solve that equation. Okay, moving on to number 47. Okay, we are solving this equation, and let me look at my sheet here real quick. Okay, we are going to factor. Obviously, we have one side equal to 0, so you're welcome to look at this as x squared plus x minus 12, and so lead coefficient of 1 makes this pretty easy. So what two numbers multiply together give you a negative 12. When added, it'll give you a positive 1. It'll be a positive 4 and a negative 3. So x plus 4, x minus 3 equals 0. So tangent of x plus 4, tangent x minus 3. Okay, now take each group and set each group equal to 0. So if we did that here, we'd have tangent of x equals negative 4. Then take this group here and set equal to 0, and bring the negative 3 over. We'd have tangent of x equals 3. Now, using your calculators, see second tangent negative 4 would give me negative 76 degrees. Okay? Now, second tangent of 3 would give me 70, I'm rounding, guys, 72 degrees. Now, students, think about this. Come on. If you'll look at the directions, we have to include all of the answers that fall between 0 and 2 pi. So think this through, guys. Come on, look. We've done all of this work, and we've worked the whole problem down to this right here. These answers, okay? Now, in other words, I want to know the angles that when I take tangent of this angle here, gives me a negative 4. So tangent is negative here, and tangent is negative here. So I'm going to put 76 here and 76 here. Do you see, students? One of their answers here is negative 76. However, that does not fall in your domain over here. Okay, it has to be between 0 and 360. So I'm going to start here and go like this. One answer would be 104. Okay, and then start here and go like this. And one answer is going to be 360 minus 76, which is 284. Now, students, understand that 284 is the exact same thing as negative 76. I mean, look, whether you go this way here, 284, or whether you go this way, negative 76, it's the same thing. However, because of your domain right here, you cannot use negative 76 for an answer. Your answers have to lie between 0 and 2 pi, or 0 and 360. Okay, now let's come over here. We want to know tangent of what angle gives us a positive 3. Well, tangent is positive here, and tangent is positive here. So put a 72 here and a 72 here. Rotate to here. There's one answer. And then rotate from here all the way to here. So we have 180 plus 72. Which would be 252 degrees. So these are your 4 answers. Okay? Now, if you convert them to radians real quick, I'm not going to do them all, but 104 degrees right here would be 26 pi over 45. Okay, there's one. I'll do one more over here. 252. It would be 7 pi over 5. And there we go. Okay, so here's your 4 answers. Let's move on to number 51. Okay, 51. Now, the directions for 51 say to find the exact values of sine, cosine, and tangent by using a sum or difference formula. Okay, now, I would strongly encourage you to use degrees, okay? Believe me, it's a smart thing to do, okay? So, this here is, hold on one second. (375 degrees). Okay? And 11 pi over 6 is 330 degrees. And pi over 4 is 45 degrees. So here's what they want us to do, students. They want us to find the sine, cosine, tangent of what angle? 375. But they want us to do that using exact answers. So what we're going to have to do is we're going to have to add these two angles together here and do it like this. Instead of finding the sine of 375, we're going to find the sine of 330 plus 45, which is the same thing as 375. Now we have a trig identity that looks like this. Let me look at my notes here. It would be sine cosine, sine u cosine v, plus cosine u sine v. Okay? Like this. And this is my u, and this is my v, okay? So what I basically have is this. Sine of 330 cosine of 45 plus cosine 330 sine of 45. Now, we know the cosine of 45 is square root of 2 over 2. And we know the sine of 45 over here is square root of 2 over 2. Now, when you see 330, don't freak out over that, okay? Remember, we just simply draw 330 degrees, and the reference angle would be 30 degrees. And then the sine sequence over here goes negative, positive, negative. So sine's going to be negative, okay? And cosine's going to be positive. Now the sine, we can use 30 here instead of 330, as long as we remember that my answer will be negative. And we can use 30 here, cosine of 30 instead of 330, as long as we remember my answer here will be positive, okay? So the sine of 30 would be 1/2, and the cosine of 30 would be square root of 3 over 2. There we go. And now bring down your plus sign, multiply these two fractions together, negative square root of 2 over 4, multiply these fractions together, plus square root of 6 over 4, okay? And notice both fractions have a common denominator of 4, so we can just put 4 in the bottom and put square root of 6 minus square root of 2. And students, that's totally sufficient, okay? It's totally fine. So now, moving on, let's do with cosine, okay? So cosine of 375. So we're going to have this right here. We're going to have cosine of 330 plus 45. And that breaks down to this right here. Let me look at my notes here. We'd have cosine of 330, cosine of 45, minus sine of 330, sine of 45. And students, we just found all of these in the last problem, so the cosine of 330 is square root of 3 over 2. Times the cosine of 45 is square root of 2 over 2, minus the sine of 330 is negative 1/2, and the sine of 45 is square root of 2 over 2. And here we go. Alright, multiply these together, we get square root of 6 over 4. Negative times a negative is positive, times a positive is positive. And 1 times square root of 2 is square root of 2. And 2 times 2 is 4. So your final answer would be square root of 6 plus square root of 2 all over 4. Okay? Alright, moving on to tangent. Tangent. Here we go. Tangent of 330 plus 45. Okay, now the substitution for that would be this. Tangent of u, so tangent of 330, plus tangent of v, so tangent of 45, all over 1 minus tangent of 330 times tangent of 45. So let's go ahead and get some space here. So erase all of this, erase this, get rid of this right here. And let's finish this problem up. Here we go. Alright, so in the numerator we would have tangent of 330 is negative square root of 3 over 3. Now if you're confused how I found that, remember 330 is the same thing as going like this and having left over 30 degrees right here for your reference angle. And remember, tangent is negative here. The sine sequence goes sine, cosine, tangent, okay, negative. And then if you look on your chart that you have, the tangent of 30 is square root of 3 over 3. Okay, so that's where that came from. Plus, tangent of 45 is 1 all over 1 minus tangent of 330, negative square root of 3 over 3, times tangent of 45, so times 1, okay? So next, you'll see this 1 right here, students. This 1 right here is really 3 over 3. 3 over 3, okay? And I used 3 because of my denominator over here being 3, okay? So, what I have now is negative square root of 3 plus 3, so negative square root of 3 plus 3 all over 3. That's in your numerator, okay? And down here I would have 1, and then negative times negative is positive, times the positive is positive, and square root of 3 over 3 times 1 is square root of 3 over 3, okay? So now I have 1 plus this, where I have 3 over 3. So next I would end up with this. Negative square root of 3 plus 3 all over 3 all over 3 plus square root of 3 all over 3. Okay? Now here's where it gets really tedious and boring, but here we go. I've got to take this fraction here and flip it and multiply it times the top, okay? So I'd have 3 over 3 plus square root of 3. Threes would cancel, and you're left with negative square root of 3 plus 3 over 3 plus square root of 3. So we've done really well. However, in pre-cal we do not want to have any square roots in the denominator. So now we get the crazy privilege of multiplying the top and the bottom by the conjugate of the denominator, which would be 3 minus square root of 3 over 3 minus square root of 3. Now, I've done all the work for you. If you do this correctly, you will end up with, let me look here, you will end up with, after you do your multiplying, sorry for yawning, negative square root of 3 times this, negative square root of 3 times negative square root of 3, then 3 times 3, 3 times negative square root of 3. You'll end up with this right here. 12. Let's see here. Hold on 1 second, please. You would have 9 minus 3 square root of 3 minus 3 square root of 3 plus square root of 9. Okay, that's your numerator. And your denominator would be 9 minus square root of 9. Okay, so to simplify the top, the numerator would be 9 minus 6 square root of 3 plus 3, and your denominator would be 9 minus 3. Okay, so now we would have a positive 9, and the positive 3 would be a positive 12 minus 6 square root of 3 all over 6. Well, students, look. This is an outside number. this is. So reduce all of them by 6. And you end up with 2 minus the square root of 3, which is the correct answer. Okay, that was a long problem. Here we go. Moving on to number 55. All right, the directions say to write the expression as sine, cosine, or tangent of an angle, okay? Now, students, look. If you'll notice, this is exactly what equals. Hold on 1 second here. Let me get my sheet out. My cheat sheet I'm using here that I took notes on. Okay, now students, look. If you'll notice, this is one of your sum and difference identities, okay? And this would be a u, this would be your v, this would be your u, and this would be your v. And what you would have is this. You would have tangent of, if you'll look at your trig identity sheet, you'll see that you have tangent of u plus v, because tangent of u plus v equals this right here. Okay, so really what you have is this. You have the tangent of u plus v, which would be the tangent of 35 degrees. And that is the final answer. Okay? Alright, moving on to number 59. Okay, here we go. Now, if you look in the directions, they give this to you. They tell you, I should have copied this out of the book, sine of u equals 3/4 and cosine of v equals negative 5/13. Okay? They give that to you. They also tell you that you're in quadrant number, let me look here, 2. We're in quadrant 2, okay? So, let's go ahead and draw real quick here a triangle, students, to match this scenario. So we're in quadrant 2. Here's angle u. Opposite is 3. Hypotenuse is 4. And so this other side here would be square root of 7. Now let's go ahead and draw a triangle to match this scenario. We're in the second quadrant here. This is v. And we have adjacent over hypotenuse. Okay? So the other side would be 12. Is that a 13 right there? Yeah, this should be a 13, students. Sorry, 13. There's a 13. So this should be a 12 right here. Okay, now with that in mind, here we go. If you look at your trig identity sheets, cosine of u minus v right here is the same thing as cosine u, cosine v, plus sine u, sine v. Okay? Like this. Here we go. Now what is cosine of u? We don't know. Let's find it. Cosine of u, adjacent over hypotenuse. So square root of 7 over 4. But hold it. Don't forget, students, your sine sequence for the second quadrant is sine, cosine, tangent, sine, cosine, tangent. So cosine is negative. Okay, now cosine of v, well, they gave that to us right here. Cosine of v is negative 5/13. So we know that. Plus, okay, the sine of u, well, they gave that to us right here. The sine of u is 3/4. And then the sine of v, come over here. Sine of v would be opposite over hypotenuse, so 12/13. And it would be positive because sine is, look right here, positive in the second quadrant. Okay? So here's what we would have. We would have 5 square root of 7 over 52 plus 36 over 52. So we do have a common denominator. Your final answer would be 5 square root of 7 plus 36 all over 52. Okay, there we go. Okay, moving on to number 63. Okay, we're going to solve this equation. It's going to be really tough, so please pay attention, okay? Now, first of all, students, we're going to call this U, and we're going to call this V, okay? And dealing with your sum and difference formulas, we can write this. Whenever you have the sine of two angles that are being added, you really have this. Sine of U, cosine of V. So sine of U, cosine of V. And for pi over 4, I'm going to put 45 degrees. Plus cosine of U, sine of V. Now we're going to run out of room here. This entire expression right here was substituted for this right here. Okay, now we still got to do this over here, okay? So here we go. Now make this a little smaller. Alright, there we go. Now let's deal with this. Now be careful, students, with this negative sign here. Okay, I would encourage you to bring it down, put it here, and then put a bracket so that you know everything inside here gets the negative sign. It's very important. And then equals 1, okay? So here we go. You have sine of two angles that are being subtracted. Okay, so here's your U, and here's your V. So here we go. Here's what you would have. You would have sine x, cosine of 45 degrees, and instead of a plus sign like we had over here, you'll have a minus sign, and then be cosine of x, sine of 45. Now we're going to solve this equation. Okay, before we do, look, there's a negative sign here, students, that we can multiply through. So watch this carefully, okay? If I took this negative sign and multiplied it through, a negative times a positive would make this become negative, and a negative times a negative would make this positive. Okay? Now look what you have right here. You have a positive sine x cosine of 45, and over here we have a negative sine x cosine of 45. They're going to cancel out. Now I have a positive cosine x sine 45 and a positive cosine x sine 45. So that's 2 cosine x sine 45 equals 1. Now students, the sine of 45 is 2 cosine square root of 2 over 2. So really you have 2 times cosine times square root of 2 over 2. We'll put this over 1. And remember, when you're multiplying, you can multiply in any order you want to. So we'll take this here times this, and we'll get square root of 2, because your 2's would cancel. Cosine of x equals 1. Okay? Now divide both sides by square root of 2. 1 over square root of 2. So basically what we have, students, is this. Cosine of x equals square root of 2 over 2. Now I'm going to glance in the book and see if they gave us a domain for this problem. I believe they did. And yes, they did. So we have this domain here. 0 to 2 pi. Okay? Now, Students, we want to know that an angle, that when I take the cosine of that angle, I get out a positive square root of 2 over 2. Well, that's going to be cosine is positive here, and cosine is positive here. And the angle would be for that 45 degrees. So I put a 45 here and a 45 here. So one answer goes from here to here, 45 degrees. And the other answer starts here and goes all the way to the hypotenuse. So that would be 315 degrees. Okay? So if you're looking for radians, it would be pi over 4 and 7 pi over 4. There we go. Okay? There's your two answers. Okay, moving on to number 67. Okay, now the directions for 67 say, find the exact values of sine of 2u, cosine of 2u, and tangent of 2u. And let me look at my notes here. They tell us we're in the third quadrant because look, u is greater than 180 and less than 270. So, that means u falls in between this area right here. Okay, so here we go. First of all, let's go ahead and list out our triangle here. Here's our triangle. Let's put a u right here. And the sine of u is opposite over hypotenuse. So the missing side here would be 3. That's good. And now, let's go ahead and find the sine of, let's see, the sine of 2u. And so here we go. The sine of 2u. Well, the trig substitution for that would be 2 sine u cosine u. So 2 times, and the sine sequence over here, students, is negative, negative, positive. Okay, so negative 4/5, and then cosine would be negative 3/5. And if we put 2 over 1 and multiply all of these together, we would get positive 24 over 5. Okay, so there we go. So sine of 2u equals 24 over 5. Okay, let's move on now and let's find this cosine of 2u. Okay, so here we go. Well, let's see, the substitution we can make for this would be cosine squared of u minus sine squared of u. So cosine would be negative 3/5 squared minus sine of u would be negative 4/5 squared. So we get 9/25 minus 16/25, which would be negative 7 over 25. Okay, so cosine of 2u equals negative 7/25. Now students, look, learn to think and reason, okay? Before you do this right here, put tangent of 2u, and then put this, the big formula, or the big identity, 2 tangent of u, 1 minus tangent squared. Think for a second, students. Look, we don't need to do that at all. Think of your basic trig identities. What is tangent of 2u equal? Well, tangent of 2u would be the same thing as sine of 2u over cosine of 2u. Students, remember, tangent always equals sine over cosine, okay? So if we know that, if we know the tangent equals sine over cosine, look what we can do here. Look, we know what sine of 2u is. It's 24 over 5. So really, I'm going to put 24 over 5. And then look, cosine of 2u, we know what that is. Negative 7/25. So we take this and we flip it and we multiply it times the top. Like this. And so we end up with a positive times a negative would be negative. 5 cancels into 25 5 times. And actually, hold on one second, I'm making a mistake somewhere. Let's see what this would be here. 24 over 5, 7 over 25. Okay, students, I'm back here. I'm not sure where my mistake is, which, I mean, it's fine. We all make mistakes. That's fine, but I'm going to try this one more time. It's probably a little mistake somewhere, but sine would be 24 over 5, and cosine would be negative 7 over 25. So we take the bottom here and we flip it, and we get 25 over 7, like this. And then 5 goes into 5 once, 5 goes into 25 5 times, and I'm getting negative 120 over 7. Now that's not the correct answer, and I know this is right, and I know this is right, and I know my reasoning is right, so I'm not quite sure what to do here. Obviously I'm making a little mistake somewhere, and you guys can probably see it and you're chuckling at me, but I don't know where it is. Well, I'll leave it up to you guys. Maybe one of you can find my mistake and email me and point it out to me. But the answer is supposed to be, according to the back of the book, negative 24 over 7. Okay? That is what it should be. And I'm trying to figure out why this isn't working. But anyways, I'm still looking at it here. I'm kind of stumped, a little frustrated here. Okay, well, I'm not sure where my mistake is, students. I apologize, but this should be the answer according to the back of the book. So somewhere I'm making a little mistake, but this does work. Just watch your simplifying. Excuse me. Just watch your simplifying, and make sure you're being careful with your work. Okay. All right. Moving on to number 75. Okay. Now, 75. We are going to find the sine, cosine, and tangent using our half angle formulas. Okay, so first of all, this is the same thing as 285 degrees. Okay, now next, if we're going to use our half angle identities, we have to multiply this by 2, and I'll show you why in a second, and you get 570. Because remember, here's what we're going to do. In order to find the sine of 285 degrees, instead of using 285, we're going to use 570 over 2, which is the same thing as 285. Now, in order for us to do that, the trig identity is going to be plus minus, put an equal sign here, plus minus square root of 1 minus cosine of u all over 2. Now, this is your u, 570. So, what we learned is whatever quadrant u is in, that tells you whether to take the positive or the negative sign here. So, 570 would be this. It would be 360 plus 210 more. So 180 plus 30 more. So here's where we end up. Okay, right here. 30 degrees in here. 30 degrees. Okay, now, so u, 570, is in what quadrant? 3. And we're dealing with sine. What is sine in the third quadrant? Negative. So we're going to use the negative sign right here. Now, next, we'll have 1 minus, now think about this, guys, the cosine of u, which is 570. The 570 really is 30 degrees, like this, as long as you remember you're in the third quadrant, and cosine is negative. So the cosine of 570 is the same thing as the cosine of 30, as long as you remember the cosine of 30 will be negative because you're in quadrant 3. Okay, so if negative square root of 1 minus, now the cosine of 30 is square root of 3 over 2, so negative square root of 3 over 2 all over 2. Okay, now next we're going to have negative square root 1 plus square root of 3 over 2 all over 2, because a negative times a negative is a positive. So next, make this 1 right here a 2 over 2. I would have 2 plus square root of 3 all over 2 all over 2 over 1. Okay, square roots over all of this, okay? So next, I would have minus square root of 2 plus square root of 3 over 2, and then take this and flip it and multiply it times the top, so times 1/2, and so we end up with this over here, negative square root of 2 plus square root of 3. 2 times 2 is 4. Now we're almost done. This is really a mess, but anyways, we're almost done. We do not know the square root of the top. However, we do know the square root of 4, so your final answer would be negative square root of 2 plus square root of 3 all over 2. Just like that, okay? Because the square root of 4 is 2. Alright, lots of fun. Now, here we go. Now let's deal with the cosine of 570 or 285, but instead of using 285, we're going to use 570 divided by 2, okay? Equals plus minus, let's see what we have here, 1 plus cosine of u all over 2. Notice we can do this pretty fast because we've done most of the work already, okay? For example, we already know that 570 is my u, and we already know it's in quadrant 3, okay? And cosine in quadrant 3 is negative, so we're going to use the negative sign. And then next, we already know what cosine of u is. We just found it in the last problem. So 1 plus negative square root of 3 over 2 all over 2, and 1 square root of 1 minus square root of 3 over 2 all over 2. And then we'd have negative square root 2 minus square root of 3 all over 2 all over 2 over 1. And what I did from here to here is for the 1 here, I just put 2 over 2, okay? And then put those two fractions together. So if we take this and flip it and multiply it times the top, we will end up with negative square root of 2 minus square root of 3 all over 4. Now I do not know the square root of the top, but I do know the square root of 3, or excuse me, the square root of 4, which is 2. So we'll put a 2 here, okay? And that is the answer, okay? Now, tangent of, I'm not sure what I just did there, but whatever it wasn't good, I can tell you that. Okay, not liking that. There we go, okay. Now let's take a look at the tangent of, that's not good. Alright, let's see if that works. Much better. Tangent of 570 over 2 would be the same thing as 1 minus cosine of u over sine of u. Okay, so what we have is this. We have 1 minus, now from the past two problems, we already know the cosine of u is negative square root of 3 over 2. Now the sine of u would be the sine of 570 degrees. So 570, of course, is this all the way to here with 30 in here. So sine in the third quadrant is negative, and the sine of 30 degrees is 1/2. So there we go, okay? Now moving down, we'd have 1 plus square root of 3 over 2 all over negative 1/2. Okay, now make this 1 a 2 over 2, and we have 2 plus square root of 3 over 2 all over negative 1/2. Now take your negative 1/2, flip it, and multiply it times the top. Your 2's would cancel. A positive times a negative is negative. So the whole thing is negative 2 plus square root of 3, or negative 2 minus square root of 3. Okay? And there we go. That was a really long problem, but at least we're done. Moving on to number 81. Okay, students, here we go for number 81. Okay, let's see what we have here. We have, okay, if you'll notice in your product to sum and sum to product identities, if you'll look at those, whenever you have cosine times the sine, this would be your u right here, and this would be your v right here. So what we would have is it equals 1/2, and then bracket, and then sine of, you'll find all of this on your trig identity sheet, students. U plus v minus sine of u minus v. Okay? So with that in mind, here we go. 1/2 sine of u plus v. So pi over 6 plus pi over 6 would be 2 pi over 6, which reduces to pi over 3. Okay? Then minus sine, and then we have u minus v. Well, pi over 6 minus pi over 6 would give you 0. Okay? There we go. So really, what we have now is this. We have 1/2 times sine of pi over 3 minus 0, because the sine of 0 is 0. So really what we have is just sine of pi over 3 minus 0 is just sine of pi over 3. So your final answer would be 1/2 sine of pi over 3. Okay? That would be your final answer. Okay, moving on to number 87. This is going to be really, really, really weird, okay? If you'll look at your trig identity sheet, you will see an identity that looks like this on your sum to difference and difference to sums. You will see one that looks like this. Cosine of, let me look at my notes here, x minus cosine of y. Now here's what's really weird. We're going to call this whole thing here x. This is really weird, okay? And we're going to call this whole thing here y. Okay? So here's what we know. Are you ready? Since we're doing that, if you look at your trig identity sheets, what we have is this. We have -2 sine x plus y over 2 sine x minus y over 2. Okay? Now, remember, this whole thing here is my x, and this whole thing here is my y. Okay? So, let's do this in our head, okay? It'll really help if we can do this in our head. Now watch. X plus y. So this whole thing here, x plus pi over 6, plus this whole thing over here, x minus pi over 6. Well, look, here's a positive pi over 6. Here's a negative pi over 6. They cancel. X plus x is 2x. So you're left with 2x over what? 2. Well, 2x over 2, your 2's cancel. It's just x. So there we go. Pretty simple. Now let's continue on. Sine of x minus y. So let's try to do this in our head down here. Okay, look. Here's your x right here. X plus pi over 6. And then it's minus y. So it's minus this whole group here. X minus pi over 6. So really you end up with x plus pi over 6 minus x plus pi over 6. We have a positive x and a negative x that cancel out. Pi over 6 plus pi over 6 would be 2 pi. 2 pi over 6, which is really pi over 3. So you have sine of pi over 3 all over what? 2 over 1. Now, take your 2 over 1, flip it, multiply it times the top, and you would get pi over 6. Like this. There we go. And that is your final answer. Okay? All right. That's the end of part one of the review sheet. And go ahead and start part two now, whenever you're ready, okay? I hope this has been a help to you guys. My voice is really bad, I'm sorry, but I hope this has been a help to you. If you have any questions, don't hesitate to call or email.